Hi, this is Mr. Max. So I am going to do a series, a two-part series on histograms. All right. So what you need to know is that a histogram displays data using bars. Now you do have bars that will have equal widths, and also I'm going to do bars that have got, obviously the widths are not equal, and the different heights also play a role, and so will something that we're going to call the frequency density. All right, so we're also going to look at things like class interval. Now, what is very important that histograms, they show continuous data such as weight, height, or how much time, all right, and also what is necessary for you to understand is when one class ends, the other one starts. So we're going to also indicate that by an inequality. Right, so according to the syllabus that you are following, you're supposed to construct and read histograms with equal and unequal intervals. All right, the areas are proportional to frequencies, so that is very important. And you will see also something very important is that the vertical axis is going to be labeled frequency density. All right, so let us just look at group data with equal class intervals. All right, the widths of the rectangles are constant. All right, so let's just jump directly to a question. So this question says here, the number of cell phones sold each year over a period of 19 days were recorded. So you have got the number of cell phones between 0 and 5 cell phones, 9 were sold. Between 5 and 10, 5 were sold. And between 10 and 15, 2 were sold. Between 15 and 20, 2 were sold. And between 20 and 25, only 1 phone was sold. Now, from this information, you are asked to draw a histogram. So you look at the intervals here, it's going to be 5. 5 minus 0 is 5. 10 minus 5 is 5. 15 minus 10 is 5. 20 minus 15 is 5. And 25 minus 20 is 5. So we're going to have equal intervals. The rectangles will be the same width. And then the second part that we are going to look at is on how many days were the number of cell phones sold more than or equal to 15. Well, we will have a look at that. Okay, so let's bring that table back and let's draw our histogram. So it's very easy. You see that it starts from 0 to 5 all the way up to 9 as indicated. So you can see my vertical axis is labeled frequency. My horizontal axis is labeled the number of cell phones. All right. And you have got between 5 and 10, for example, 5, the bar goes all the way up to 5. So the class intervals are the same. So therefore, the width of the rectangles are exactly the same. Now, the B part of that question, on how many days would the number of cell phones sold more than or equal to 15? Right, so on how many days were they more than or equal to 15? So between, if you look here, more than or equal to 15, so that is here between 15 and 20 or between 20 and 25. So it's basically essentially the 2 here plus the 1. So that's 3 days there. Let's bring in a second question. We are still dealing with widths of that are equal in terms of the information, the class interval that we are given. So we have a table here, and it shows the waiting time in minutes for 36 patients at the doctor of a clinic. So when you obviously look at this, is 9 rows or 9 columns times 4 rows, that gives you 36. Somebody waited 14 minutes, another person 22 minutes, and so on and so on. So they are saying you're supposed to use class intervals of 5 between 10 and 5, between 15 and 10. The next one is going to be between 20 and 15, and so on and so on. And you're supposed to construct a frequency table for this data. Then you draw a histogram. So since the class intervals will be the same, the histogram or the rectangles on your histogram will be the same width, and they are starting at 5. Very important that you take note of that. All right, so what I did first, I constructed my table, and then I had a frequency. So I'm picking from my raw data that is there, and I found between 5 and 10 is 2, between 10 and 15 is 6, and so on and so on. The tallies are helping me to find the values. So everything should add up to 36, and that is where you must make sure you add your frequencies. And if your frequencies don't add up to 36, because this is 9 times 4 here, then you have made a mistake somewhere here with your data. All right, so let me just bring that table here. And what I have done is, you see from the histogram that I drew, the y-axis is labeled the frequency because there's the number of times. Obviously, the higher the bar, that represents the highest class interval, the modal class interval. All right, because the frequency here directly tells you which group had the most or weighted the most and stuff like that. Okay, so it starts at 5. Where one ends, the other one starts, even though between 5 and 10, for example, 10 is not included, but the bars must touch each other. And again, because the class intervals are exactly the same, the bars have got exactly identical widths. Right, so let us then do what is necessary, and that is a histogram for group data with unequal class intervals. Now, when we do histograms with unequal class intervals, then the intervals, because they are different, the rectangles will not have the same width. And also, to then make the histogram fair, the area of the bars are the ones that we are going to consider. All right, and they should be proportional to the frequency. All right, so the area of the bar should be representing the frequency. And on the vertical scale, we don't plot frequency anymore, but we're going to plot what we call frequency density. Okay, so how you find frequency density is you take the frequency, you divide it by the class width. This is very important that you understand this, and perhaps we can play around with this formula to find the frequency. Then you multiply the frequency density by the class width. That is like essentially make f the subject of the formula. Ultimately, to find the class width, you take the frequency and you divide it by the frequency density. This is just something that you can play around with, all right? But the most important one is finding the frequency density, which is the frequency divided by the class width. So you will have to identify the class width when we are dealing with questions like that. So I'm bringing a question here. It says, on Sundays, Lei helps her grandfather feed their chickens over a period of 1 year. She kept a record for how long it took, and then she recorded the results below. So as you can see, between 0 to 30, about 8 times. All right, and also then included the class width, because if you take 30 minus 0, you get 30. And here you can see the class width will be 15, and the class width will be 15, and so on. And the last one, the class width is 30. That's 120 minus 90. So the question will ask us to complete the table by calculating the frequency density. Remember, frequency density is calculated by taking the frequency, dividing it by the class width, and give it to one decimal place. You get about 0.3. The same applies. 5 divided by 15, it's about 0.3. 8 divided by 15 is about 0.5. 9 divided by 15 is 0.6. 10 divided by 15 is about 0.7. And 12 divided by 30 is 0.4. So all of these are necessary to one decimal place, because it's going to help me with plotting of the graph, okay? Right, so they are saying here you are using a scale of 1 centimeter to represent 15 minutes. All right, draw a horizontal axis from 0 to 120, and then using an area scale of 2 square centimeters to represent 3 days, draw a histogram for this data. So first of all, let's look at what the horizontal axis look like. So from 0 to 15 is 1 centimeter, so 2 centimeter will be like 30. Okay, right? And then if I bring in, suppose I take this rectangle here, and I bring this rectangle here where this one has to be. It's 2 centimeters by 1 centimeter, because the area is 2 square centimeters. This particular area represents 3 days. Now, we know then from our data that if we have got an area of 3, the frequency is 3, okay, then we have got the 30 times something, all right? 30 times L, and that L that we're looking for is the length of our vertical axis, all right? So this is basically coming from my table, right? So now, if you look at what I mean by that, so we have got a 1 centimeter here on the vertical axis represents, okay, 0.1. Okay, so because you have got 0.3, so 1 represents 0.1 centimeters, and so on, and 2 represents 0.2, and 3 centimeters represents 0.3 centimeters. Now, if you had to calculate the frequency density, for example, or the frequency, you take the frequency density. Remember, it is not exactly 0.3, it's about 0.2, 0.666, or 2.2666 recurring times 30 gives you 8. All right, so we're going to have a look at this in detail again as we go on with this question. So let me just bring back my table with my frequency and with my frequency density. All right, so now what is important, and if you did not get that information from the beginning, all right, from the table, it is very apparent that you can see that 1 centimeter here, this is this distance here, 1 centimeter here, all right, represents that height is about 0.1. Okay, and here we knew from our information that 1 centimeter should be 15 minutes. Okay, now if we are taking a class interval like you will see between 0 and 30, because we are supposed to complete this. All right, so let me just clean that up so we can complete our table. The point 1 is very important. It guides you, it tells you exactly the values that you should have here for your frequency density. Okay, that is very important. So the first one here, if you look between 0 and 30, it is about 0.3. So it has to go from here up to 0.3, and that is the region here that we get. So this frequency of 8 is supposed to be the same as the formula to calculate the area of this particular rectangle here. Okay. Then the second one that you're going to get also goes up to 0.3, but then the class interval there, as you can see, is just 5, so it's between 30 and 45. The next one is going to be between 40 and 60, or between 45 and 60 rather, and the next one is going to be between 60 and 75, and the other last one there is between 90 and 120. So this is how, when you represent this information on your histogram, is going to look like. You can see that the first rectangle, the last one, the widths are not the same. They are 30, and because the widths are not the same, because the class intervals are not the same, the widths of the rectangle are different from the others. All right, so when we are looking at things like modal class, we're going to consider the one with the highest frequency density. Okay, and in this particular case is between 75 to 90, and that would be generally referred to as the modal class interval. All right, let's bring in another question. Perhaps this one is going to help us nicely understand the vertical axis. So we've got 15 students. They are timed when running 1 kilometer. The results are shown below. So they are running a 1 kilometer race. So here you have got the time. Those who did between 4 and 4.5 minutes, they were 2, and the frequency density you calculate is 4. Remember, where you get the frequency density is you take the frequency, you divide the frequency by the class interval. So when you take 2 divided by 0.5, you get 4. When you take 7 divided by 0.5, you get 14, and so on. All right, if you can also have a look here, you will see that the class intervals for all of them here will exactly be the same. So because the class intervals are exactly the same here, the height of the bars or the width of the bars will be the same, and the one of the highest bar will be this one here between 5.5 and 6. However, what you must realize, and that is what I was saying, the highest frequency, but when you are dealing with different weights, the modal class is the one with the highest frequency density. So in this particular case, I've indicated in red the modal time interval. It has got the highest frequency density, and also because the bars are the same, because the class intervals are the same, it also has the highest frequency. But the frequency density tells us where the modal time interval is. Right, so they expand the question. They say you are supposed to calculate the estimate of the mean. Now, the way you calculate the estimate of the mean, and why the mean is an estimation, is because you don't really know you know that 2 people have times between 4 and 4.5 minutes. You know, for example, 18 people have between 5.5 and 6 minutes, but you don't know exactly each individual person's time of those 18. So what we do is we average out that time. So we are going to find the mid interval. That means you take the first and you add with the last, the 5.5 plus the 6, for example, and then you divide by 2. So we average out the times there, right? So on average, the average time here in this class interval was about 4.25, and the average time in this interval here was 4.75, and the next one is 5.25, 5.75, 6.25, and the average time for the last one is 6.75. Now that we have the mid-interval values, and in order for us to calculate the mean, since it's an estimation, we take that mid-interval value, we multiply it by the frequency, and we add, and we do that, and then we divide by 50. 50 is the sum of the frequency. And the moment you do that, you get an estimate of about 5.67. Pause the video just to make sure that you understand that particular concept when you are supposed to calculate the mean, because it's an estimation, because you do not have the exact values for each and every person. The data is grouped here. Now, they are bringing in a new frequency table from the results from this table here. So you are supposed then to complete. So if you look at the people who have done between 4 and 5.5, 4 and 5.5, now that goes from 4 all the way up to 5.5. So you have to add then 2 plus 7 plus 8, because it's from 4 up to 5.5. All right, then from 6 up to 7.0, it's going to be this 10 plus this 5, which means it's 15. All right, so you can see we're spread it out more, and if you have to do this on a histogram, it's going to be a different width, because all the other ones from the first instance, the widths were the same. So they just decided to group more. They take from 4 to 5.5, and not like from 4 to 4.5. But it should be clear for you that between 4 and 5.5 minutes, it is about 17. That is adding the frequency that you get. And between 6 and 7 minutes, it's 10 plus 5, it's 15. Right, so now we are going to calculate the frequency density, right? So the frequency density is take the frequency 17, you divide now by the class interval. All right, that's about 11.3-ish, and then you have got 6. The frequency here is going to be 18 divided by 0.5, because 6 minus 5.5 is 0.5, the class width there. And so the frequency density is 36, and between 6 to 7 minutes, you take 15 divided by the class interval here. The class interval is just 1, so that gives you 15. So if they are asking you now to complete this histogram, all right, so we can complete this one. This one has been done. It's between 5.5 and 6. It's here already, so we just need to complete the other ones. So the other one starts from here, 4 up the way up to 5.5. That is what we are looking at, and the next one is going to be between 6 and 7. All right, and it's very important that you also see how my frequency density scale is. All right, so I decided 1 block to represent 1 unit. Okay, and 11.3 is about somewhere in that area there, in that region that you can see. Now, something also that's worth mentioning is that this little break that you see here, it indicates the scale does not start from 0. Obviously, as you can see, the data starts from 4 to 7, so cannot start from 0. So that break is indicating you, okay, there's no scale before this 4 mark here. All right, so that is something that if you come across it, you should know that it means that you do not start drawing your bars from 0 if your data doesn't start from 0. A third question says 120 passengers on an aircraft had a baggage weigh, and the results show in the table. So between the mass of between 0 and 10, 12 people who had a mass between 15 and 10 is 32, and so on and so on. All right, so they want us to calculate, or to identify rather, the modal class. Remember, the modal class in group data is the one that has the highest frequency. So what I did is I took the class widths, and I also then calculated the frequency density. Remember, frequency density is calculated by taking the frequency then you divide it by the class width. All right, so please don't forget that the frequency density is calculated by taking the frequency and then you divide that by the class width. So for example, the first one here, I took 12 and then I divide 12 by 10, and that is how I get the 1.2, for example. So now that I have done that, I can actually identify the one of the highest frequency density. And as you can see, the one of the highest frequency density is obviously the interval between 10 and 15, because between 10 and 15, the frequency density there is 6.4. Therefore, it represents the modal class. Now they are saying we're supposed to find the estimate of the mean. All right, so this is going to be exactly the same. We have to find the mid-interval values. Okay, so I did the mid-interval values. So you add 10 plus 0, half of that is 5. 15 plus 10, half of that is 12.5. 20 plus 15, half of that answer is 17.5, and so on. And now if I have that, I multiply the mid-interval times the frequency and I add them, mid-interval times the frequency, mid-interval times the frequency, and when I add them, then I divide by the total number of frequency. All right, so once you divide by the total number of frequency, you should definitely arrive at an answer of 18.9. Okay, now using a scale of 2 centimeters to represent 5 kilograms, draw a horizontal axis between 0 to 40, basically everything. All right, starting at 0 as you can see, and I have my frequency density here, and I have my frequency. Now, what is important is this part here, the 1 square centimeter must represent 1 passenger. Now, the horizontal one is quite straightforward. They say between 0 to 5 kilograms is 2 centimeters. That is fine. You should be able to do that. The catch comes with the vertical one. So how do I then find my 0.4 here that you see? I'm starting from 0.4, 0.8, and so on. So it is this indicator here, because remember, it's supposed to be 1 centimeter times 1 centimeter. But now, half of 5, because from 0 to 5 is 2 centimeters. So half of that is 2.5. And so that is why I have this particular distance as 2.5 here. Okay? So now the area says the one person, maybe I should write under that so you can see the one person here is represented by that 1 square centimeter. So the frequency, this one, is equal to the area under the rectangle. So 1, which is the area, should equals to the length, which is this particular length from 0 to 0.4 that I'm looking for, because this is a square. Okay, so it will indicate to me now what are my intervals going to be. So now I have got 1 is equal to the length times 2.5. Well, then to find the length is 0.4. So one little square or 1 centimeter on the y-axis will represent 0.4 as you go along. Okay, and that is very important that you need to understand that. Okay, and if you multiply 0.4 times 2.5, you're going to get 1 here. All right, now that I know I have got 0.4, now I'm going to increase. It's going to be 0.4 for 1 centimeter, another one 0.8, another one 1.6. So it increases every 0.4 times. Okay, now that I know, I can now start with my histogram. So now, as you can see, I already skipped, but it's 0.4, 0.8, and so on. I know the highest point is 6.4. I label my axis. All right, so on my graph, everything should be fine. Now, it's just a matter of you then drawing. So between 0 and 10, your highest density, your frequency is 1.2. So you must make sure where 1.2 is. And also the next one now, 6.4. So it's 10 to 15, all the way up there. And then the next one is between 15 and 20, and it's 5.6. And also between 20 and 25, it is going to be 4.8. And the last one between 25 and 40 is 1.6. And you can see I have done my histogram now.